Chapter 3. Welcome to the Solar System Anomaly Number 1, the nearly perfect entry. In early July 2025, an unusual object was detected at the edge of the Solar System, only the third confirmed interstellar object in history. What is an interstellar object? It is a body whose origin is not within the Solar System. We know this because it arrives with hyperbolic velocity, a speed too high for the Sun to have captured it. In other words, it came from outside. The first anomaly, an almost perfect entry into the planetary plane. The object entered the Solar System almost exactly along the ecliptic plane, the plane in which all the planets orbit the Sun. Its deviation was only about 5 degrees, a measured, documented value. In addition, its hyperbolic path lined up with 3 planetary encounters, each occurring within a relatively small window of time, a statistical rarity. Why does this matter? A natural interstellar object should enter from a completely random direction, anywhere across a 180-degree celestial hemisphere. The planetary plane is a thin line within that hemisphere. Probability of entering within plus or minus 5 degrees of the ecliptic, 1/10 of 180 degrees, is approximately 0.055, which is 5.5%. But this is only the geometric probability. In practice, it is lower because objects do not need to pass close to the Solar System's center. A conservative, widely accepted estimate, 2 to 3%. That matches what was found for both Oumuamua and Borisov. But now comes the crazy part, the probability of close encounters with 3 planets. Planets are in constant motion, each moving on different orbits at different speeds, occupying only a tiny gravitational volume compared to space around them. For an interstellar object to 1. Enter exactly the plane, 2. At the right time, 3. Synchronize with 3 planets, 4. And pass through meaningful encounter distances, it would need to hit a sequence of conditions whose probability is astronomically small. It's like dropping a needle from orbit and hitting 3 different coins on the floor simultaneously. Approximate astrophysical probability. Probability of 1 planetary encounter within a short window, 1 in 1,000 to 1 in 10,000. 3 planets in sequence, 10 to the power of -3 times 10 to the power of -3 times 10 to the power of -3 equals 10 to the power of -9. Now add the 2 to 3% chance of entering the plane. 0.03 times 10 to the -9th equals 3 times 10 to the -11th. Natural probability of this anomaly, about 1 in 100 billion. This extremely rare configuration is almost impossible to get by accident. But for a technological object, this is exactly what you'd expect. A technological probe, regardless of propulsion method, would choose to enter the planetary plane to map the system, time its encounters with planets to gather data, use gravitational fields for measurements or navigation, perform small, precise course corrections, use the ecliptic as a stable observational frame. In other words, such a trajectory is not only plausible, it is expected. And what about electromagnetic propulsion? It allows fine-tuned trajectory control, continuous thrust with no visible exhaust, small adjustments that accumulate into extreme precision, a smooth descent directly into the planetary plane. Such a propulsion system makes a precise entry not just possible, almost trivial. Summary: Anomaly number 1. Even before we saw tails, jets, thermal behavior, or speed changes, the object executed a maneuver that has almost 0 natural probability, fits seamlessly into a technological model, matches what electromagnetic propulsion can easily achieve. This is only the first anomaly. If it stood alone, maybe coincidence, but it is the first in a sequence. Anomaly number 2. The polarization mystery, light behaving the wrong way. While 3.1 Atlas was still far from the Sun, Long before it was close enough to heat up, sublimate, or develop a significant tail, the first measurements of its linear polarization arrived. And with them came one of the most disturbing anomalies in the entire dataset. At phase angles between 7 degrees and 22 degrees, the object showed deep negative polarization, -2.7%. For those unfamiliar, linear polarization describes how light aligns after reflecting from a surface. Almost all natural solar system bodies, asteroids, comets, dust grains, behave according to well-studied, consistent polarization patterns. Hundreds of bodies have been measured. The models are extremely solid, but 3.1 Atlas broke the pattern. Why does this matter? 1. It was far from the Sun. At that distance, there should be no significant sublimation, no dust cloud, and no scattering envelope capable of producing strong polarization. Yet the readings showed unusually deep negative polarization. 2 to -2.7% is extreme by interstellar standards. This is far outside the normal range for asteroid or comet-like bodies. Producing such a value requires an unusual surface, mirror-like micro-smoothness, highly ordered microstructures, crystalline or plate-like symmetry, or a surface that reflects light directionally. 3. The polarization appeared before cometary activity began, meaning the mechanism must be rigid, stable, and not a byproduct of gas jets or natural dust. What does this imply for our hypothesis? If the object is natural, we must somehow explain how an anonymous interstellar body far from the Sun, with no dust cloud and no thermal processes, produces an optical signature that behaves like a fabricated surface. By contrast, under a technological interpretation, a manufactured surface, especially metal, thermal ceramic, or any material with uniform crystalline alignment, would naturally produce deep negative polarization at low phase angles. And here is the part we added from our own model. Electromagnetic thermal regulation systems. Certain EM-based thermal control arrays can produce stable negative polarization signatures even when the object is far from the Sun, by redirecting charged particles or generating structured scattering patterns around the surface. In other words, what is strange for a natural comet is straightforward for a controlled, engineered surface or system. Summary: Anomaly number 2. Anomaly number 2 does not say, "This is alien." It says something more subtle. The object reflects light like a surface, not like a rock. And that alone is unusual, unexpected, and demands explanation. In the next chapter, we'll continue down the rabbit hole. Subscribe, leave a like, and stay at the cutting edge of boundary-pushing science.